In this video, we will be discussing about first completely painted row or column. You are given a zero indexed integer array ARR and an m cross n integer matrix mat. ARR and mat both contain all the integers in the range 1 to m cross n. Go through each index I in the array starting from index 0 and paint the cell in matrix containing the integer ARR of I. Return the smallest index I at which either a row or a column will be completely painted in matrix. So what they are saying is that in the input, we are given an integer array ARR and we are given a 2D integer array matrix which is representing this particular matrix, right? Now, the size of this matrix is m cross n, right? And the elements present in this particular matrix are unique and all of them are in the range 1 to m cross n. So here the size is 3 cross 3. 3 into 3 is 9. So all the elements will be in the range 1 to 9, right? And the array is also of the same size and it is also having all the elements from 1 to 9 and all the elements are unique, right? So now what they are saying is that initially all of these cells in the matrix are unpainted, right? And then we start iterating inside the array. So here the first element is 2. So at whichever cell this particular 2 is present in the matrix, that particular cell we can mark as painted. So this cell is painted now. Then next is 8. So 8 is present here. So this cell will become painted. Next is 7. This will become painted. Next is 4. This will become painted. Now if you see over here that this entire column has become painted, right? So at which index of the array the entire column became painted? At index 3. So this index 3 we need to return as our answer, right? So basically the first index in this array at which an entire row, or I will write here an entire row or an entire column of the matrix becomes painted, that first index we need to return as our answer, right? So basically the smallest index in the array at which an entire row or entire column became painted. So in our particular case at index 3 we got a column which became painted, completely painted, right? So this index 3 we will return, right? So now, for solving this problem, the brute force approach would be to do what the question is asking us to do. Exactly that we start iterating in the array, we get a number, we find its corresponding position in the matrix, and then we mark it, right? How do we mark it as painted? So we know that all the elements in the matrix originally are positive. So whichever are the painted cells, you can mark them as negative, right? And then as soon as you mark it as negative, you can check this entire column and this entire row, right? If in this entire column all the elements are negative, you can return this index of the array. Or if all the elements in the row are negative, then also you can return it. Otherwise, you will move on to the next element, right? So now approach wise, this is okay, but this approach will be very inefficient. Why? Because the maximum length is 10 to the power 5 of this array as well as of m cross n, right? So this approach if you will implement, so it will give you a TLE, so we will have to optimize it, right? So let's see what all things can be optimized. So at each of the point we are trying to find its position in the matrix, right? The 2 is present at 0 comma 1, 8 is present at 2 comma 0. So what we can do is, since we know that the elements in the matrix and the array are unique and all the elements of the matrix are present in the array, so beforehand itself we can store the index of each of the elements in the matrix, right? So basically we can create a map. In that map we can store the indices of all the elements. So all the elements are from 1 to 9, right? So these are the elements. Now we can store their indices. So in the matrix, the number 1 is present at 1 comma 0. So we can store a pair of 1 comma 0 over here. 2 is present at 0 comma 1. 3 is present at 0 comma 0. 4, 1 comma 1 and so on. Like this we can store, right? Now you do not have to iterate inside the entire matrix to find out the position of a particular element. You can take it directly from the map in constant time, right? So now here the first element is 2. So its position is 0 comma 1. So you can mark it. Now again you will have to go through the entire column and entire row to check whether it is completely painted or not. Now we need to optimize this as well, right? So how this can be optimized, right? This also we need in constant time. So to do so, what we can do is that we can maintain two arrays. One will be the row count and the other one will be the column count. right? So basically the row count array will be equal to the number of rows that you have in the matrix, which is 3 in this particular case. So we can create an array of size 3, and then call count array's size will be equal to the number of columns that you have in the matrix, which is 3 in this particular case. So we will create an array of size 3, right? This is 0 1 2 0 1 2, and initially we can keep all the values in these arrays as 0, right? Now as soon as we start painting, so the first element is 2 over here, right? It is present at the index 0 comma 1. Row is 0 and column is 1. So in the row count at the index 0, we will increment by 1, and in the column count at the index 1, we will increment by 1. So this particular number is denoting that in row 0, there is one element which is painted, right? So whenever you are updating these arrays, you can check that does this number became equal to the number of rows or the number of columns, basically. So if this number becomes 3, then you can say that at this particular index in the array, an entire row has been painted. So I will return this index. Or if in the column count this particular number becomes 3, so you can say an entire column became painted at this particular index of the array. So you can return that index, right? So this is what we can do. So here the next element would be 8, which is present at 2 comma 0. So this will become 1, this will become 1. Next we have 7 present at index 2 comma 1. So this will become 2, this will become 2. Then we have 4, which is present at index 1 comma 1. So this will become 1 and this will become 3. Now this number 3 has become equals to the number of columns at the index 3 of the array. So we can return this, right? So now if you see over here that first we would be iterating in the matrix, in the entire matrix for building this map, right? So this will take m cross n time, and then you will be iterating in this particular array. So this will be added here, right? And then inside this everything is constant. The index of 2 you can get from the map, and then through the index you can mark the row count and column count, and then you can check it with the total number of rows and total number of columns. So all the operations are constant, and in this array now it might be possible that you have to traverse it completely. So maybe, and the size also can be m cross n, so we can consider that also as m cross n, right? So basically it will be somewhere around m cross n, the time complexity, right? And the space complexity, if we see, so you will be creating a map, right, of all the elements, which will be of size m cross n, and then you have a row count and a column count. So m plus n. So somewhere around this will be your space complexity, right? So let us look at the code. So I won't be writing it, otherwise the video will be too long. So here if you see, first of all, we have taken the size of the matrix, which is m cross n, and then we have created a vector row count equal to the number of rows and a column count equal to the number of columns. And then we have taken an unordered map to store the index of each of the elements, right? And its name is number to its corresponding position. Now, what we are doing is that we are iterating for each row and each column in the matrix, and then we are getting its value. So whatever is its value, we are updating it in the map, right? So the value is a pair over here in which we have row and column, right? Now we have started our iteration inside the array, right? And we are getting the number, whatever is the number that we need to find out in the matrix, right? So through the num2 position map, we are finding out its corresponding row and column, right? So that particular row we are updating in row count by incrementing it by 1, and that particular column in the column count we are incrementing by 1. Now if this particular index in row count becomes equals to n, or if this particular index in the column count becomes equals to m, then we are returning this particular index, right? Now according to the problem statement, your answer will always be there, right? Your code will always return from this particular line only, but to avoid compilation errors, we will have to return something from here also. So we can just return a -1. -1 is nothing but a dummy value, right? So if I try to run this, so if you closely look here, one thing to observe is that in the row, we are checking it equal to the number of columns, right? Because a row will be having how many elements? Equal to the number of columns. And a column will be having elements equal to the number of rows, right? So this point you should keep in mind, right? Now there is another approach. So let's look at that approach as well. So if you closely look, if I check the first row, 3, 2, 5, and if I find out that at which indices in the array will it get painted, right? So see, 3 is present at index 5, 2 is present at index 0 and 5 is present at index 6. So then that means for painting the first row completely, we will have to iterate till index 3 in the array, right? Basically the maximum index that we need to move in the array for painting the first row will be index 6, right? So I will write it here. Then if we check for the second row, 1 is present here, 4 is present here and 6 is present here. So the maximum that we have to go is index 7. Then for the third row, 8 is present here, 7 is present here, 9 is present here. So maximum we will have to go to index 8. Then if we check for the first column, 3 is present here, 1 is present here, 8 is present here. So maximum we have to go till index 5. Then we have 2, 4, 7. 2 is here, 4 is here, 7 is here. So maximum we have to go to index 3, right? And then if we check for the last column, so 5, 6 and 9. So till index 8, right? So which is the smallest index out of these? That is 3, which is our answer, right? So basically these are denoting, this is denoting that for painting the first row completely, till what max index do we need to go in the array. This is denoting for painting the second row completely, at which max index do we need to go in the array, right? Now we need to return the smallest index from the array at which an entire row or entire column became completely painted, right? So the smallest index is this 3 at which the second column became painted completely, right? So basically here we will create a reverse mapping, right? Here we need to know that number 3 is present at which particular index in the array. Earlier we were storing that 3 is present at which index in the matrix. Now we will store 3 in the matrix is present at which particular index in the array, right? So basically you can create a map again of all the elements, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you can store their values in the array, right? So 1 is present at index 4, 2 at 0, 3 at 5, 4 at 3, 5 at 6, 6 at 7, 7 at 2, 8 at 1 and 9 at 8, right? So these are the indices. Now what you can simply do is that first you can check for the first row. So you have 3, 2 and 5. 3 is present at 5, 2 is present at 0 and 5 is present at 6. Now out of these 3 the maximum is 6. We need to take the maximum index 6, right? And then in some variable which will be your answer, you can store the minimum of answer comma this particular element, right? For the first row, whatever is the maximum index that you get, that you will keep here, right? And then same thing you will check for the second row, then third row, and then you will start checking for all the columns. So the minimum index will be stored in this answer, and at the end you can return this answer, right? So this is also one of the approach. Let's quickly look at the code for this approach as well. So first of all, let's create an unordered map, right? Let's name it MP, and then let's store the index of each and every element in the array. So int I equals to 0, I less than arr dot size, and then I plus plus, and then in the map at the value arri, we will update it to I. Basically we are storing the index of every element in the array, right? Then we can take a variable answer and we can initialize it to int max because we need to return the smallest index, right? Then let's take the size of the matrix. So M will store mat dot size, that is the number of rows, and N will store the number of columns, mat of 0 dot size, right? Then we will start our iteration. So first we will fix the row. So row equals to 0, row less than M, and row plus plus, right? And then inside this we will create a variable which will be the last index, and in this we need the maximum index, so that is the reason we will take it as int min initially, right? And then we will run a for loop for the columns. So column equals to 0, call less than n, and then call plus plus, right? And then inside this we will take the index. So the index we will take from the map, and what index in the matrix, whatever is present at the index row comma column. So this will give us the index, and then in the last index variable we will update it to the max of last index comma the index that we have got, right? And then once we are done with this particular row, in the answer we will update it to the minimum of answer comma last index, right? So basically here we are fixing a row, and then in the row for each of the values we are taking its index and we are updating it in the last index, right? And once we are done with a particular row, we are taking the minimum in the answer, right? So this will check for all the rows. Then we need to check for all the columns. So for int call equals to 0, call less than n, call plus plus, and then inside this again we will take the variable last index, which we will initialize to int min, and then we will run a for loop of row starting from 0, row will go till m, and then row plus plus, and then inside this we will take the index again. So it will be from the map, and the element will be in the matrix, the element present at the index row comma column, and then we will update it in the last index. So it will be the maximum of last index comma the index, right? And once we are done with a particular column, in the answer we will take the minimum of answer comma the last index, right? And then at the end we can return this answer. So let's run this now. So here first we are building our map by iterating inside the array, which we can say that it takes somewhere around k time, we can assume, right? And then we check for the first row or the first column, which is completely painted, right? So this will take m into n time, right? So overall we can say that the time complexity here will also be m cross n, and space complexity wise we have taken the map to store the index of each element in the array, right? Which will be m into n only, right? So we can take it as m into n. So let's try to submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.